This morning I'm going to talk about our development stack for building blockchain-based applications. We're going to do quite a bit here. So I'm going to start out with a backgrounder. Every time we talk about blockchain, you always have to sort of back the bus up a little bit, make sure everybody understands the basics. So if you've been doing this for some time, you can take a quiet nap. But I won't spend too much time there, but just enough. And then I will cover the layered approach that we're taking for building enterprise-based blockchain applications. We'll do a good number of demos and give you an idea of when you can expect certain things to be in market. So let me set some context for you. So, blockchains hit the stage pretty hard initially with Bitcoin back in 2009. Really, it went into overdrive in 2015 with the launching of Ethereum and smart contracts. But I'll talk more about that in a moment. But let's talk about what is a blockchain. Blockchain is actually an unfortunate name. More descriptive or accurate description is what we call a distributed ledger. It has these four basic pillars. And this is generalized. Different implementations will have different nuances. But the first is it uses standard off-the-shelf cryptography to create authentic transactions. So it's what we call cryptographically authentic. Using things like digital signatures and encryption, we can do things with tried and true standard encryption techniques to make sure we create authentic transactions that everyone can agree on. So that's sort of the first phase. The second phase is once we agree on these cryptographic transactions, we can then agree to share them and agree that, yes, these cryptographically authentic transactions, we agree that they are indeed authentic. So we can agree to share them. Now, that's not enough to actually tip the scales. The next is that we need to distribute this thing so that no one owns a centralized copy of this, so that we don't think someone has exclusive access to the entire set of records and can go manipulate them. We want to make sure that we distribute the ledger. That then builds some trust. And the last is a ledger. And this one's really, really, really important. If any of you took accounting, I took it in college for about 15 minutes my freshman year. And it didn't take long to figure it out. It wasn't for me, but one thing I did learn was in a ledger, when you're writing, we were using pencils at that time, actually pens, because they told us we couldn't erase. So if you make a mistake on a ledger, you can't erase it, you can't scratch through it, you can't use whiteout. You have to actually post a corrective transaction. So you can't cover up your mistakes. Everything's in the ledger. So these four things combined together actually describe accurately what this is. So it's cryptographically authentic, it's shared, it's distributed, and it's a ledger. And that ledger is immutable. You can't go back and change it. Now, once you have this ledger, you can think of it as a database, a single logical database. Then you have to figure out, all right, what's the network type? And there's two basic types. There's public. These are what we call trustless blockchain networks. So this is Bitcoin, Ethereum, and there's a myriad of cryptocurrency platforms as well. But they are essentially trustless, meaning they don't have strong identity. You don't know who's on the other end. You just trust in the cryptography that the person that you're transacting with, they hold the private key, and the transactions are authentic with those. And it works really well for currency-based systems. And then there's private networks. Private networks, again, became very popular once people started to figure out what smart contracts could do. So these are what we call semi-trusted networks. And because they're semi-trusted, most enterprise scenarios, you need to have strong identity. So things like know your customer regulations and things like that require us to know who people are. So we have different options for creating private networks. So Ethereum was the first sort of at scale blockchain deployment where you could roll out a private blockchain. This is where we actually started at Microsoft from a hosting in Azure, because everyone wanted to play with this technology. It was really, really difficult to stand up these private networks to begin with. Then second, we have Enterprise Ethereum. So we're starting to see the Ethereum ecosystem grow a little bit. So we have the Enterprise Ethereum Alliance, which now has a reference implementation called Quorum that actually came from JPMC, which uses the same code base, but it adds in enterprise features. Of course, there's Hyperledger Fabric. Most people associate this with IBM. So this is sort of their approach. And there's others like Chain and R3 Corda, and there's a myriad of them out there. So there's a lot of different options for private blockchains. So the interesting thing about this technology is it hasn't been fueled into hysteria by IT professionals. It has been fueled by the lines of business, because when business people go to these conferences and they hear the stories about what blockchain can do, it essentially flattens ecosystems and supply chains, makes peer-to-peer transactions possible without intermediaries. It basically changes lots of fundamental things in the B2B space, or the B2C, or any sort of transaction or contract that you're entering into. So it changes things at the DNA level, which introduces a whole new set of distributed and shared economics. Regulatory output becomes like a byproduct, so it relieves some of that. The auditing process if you think about these big accounting firms and they go in and do audits, and they are doing it across companies, that's no longer really necessary. If you move to some of these things, auditing is sort of built in. So these shared incentives and costs, once people start to contribute and join these blockchain networks, they share everything. The incentives, the risks, the cost, and they could potentially solve a lot of identity problems. So business people hear this stuff and they think about what the implications could be. They fall into one of two buckets. They're either fearful that they're going to be the next blockbuster, or greedy. They see an opportunity. And when you have people falling into these two buckets, they behave with a certain amount of haste, if you will. So we've seen lots of pressure, people going out to try to do proof of concepts to pilots. How many of you have done a proof of concept for blockchain? A pilot? Anybody? Anybody in production? Yeah, I never see any hands yet on that. So anyway, so lots of stuff here for people to sort of understand. But I want to back up even further and really come back to this from a non-technology standpoint and explain why lines of business people and people that really start to have that aha moment for what this sort of technology could do, what it's all about. And the first thing is, and it is primarily about trust. It's actually all about trust. So it's trust between ourselves, or us. So we start to think outside of ecosystems as I'm a participant of this, and it becomes this we concept. Sometimes we call these consortiums. So us and we. So it's about trust between ourselves to transform how we exchange value with each other. And we follow common rules. So that sounds kind of, okay, what's the big deal there? We change the way we exchange value. But we do this on a shared truth based on these cryptographic proofs. What this will do is it will revolutionize the way we execute contractual agreements between each other. And it can do this forever, essentially. It's going to simplify things. It means that we no longer have to have settlement and reconciliation between two separate organizations with their own internal systems, because they share one truth. If you start to share one truth that is cryptographically authentic, that everyone agrees on, you can begin to speed up transaction times, remove risk from ecosystems, whole sets of capabilities. So it's all about trust. So let's talk about how this trust is modeled. So the cryptocurrency case is a trustless model. So it was like a cash scenario. So let's talk about Bitcoin and the likes. So some of the characteristics of this first implementation of blockchain, the first thing they had to do is they needed a platform where you could make change. So everybody knows what make change is. You go to buy something and you have a single dollar bill. The thing costs 35 cents. I give them a dollar bill. I need to get 65 cents back, and they need to have 35 cents back. So that's making change. But it's also about authenticity. If any of you, does anybody, if you take a look and pull a dollar bill out of your wallet and take a look at what that dollar bill is, you can look at all the different things and say, what makes this thing valuable? Money is actually magic. If you think too long and hard about it, you might freak out. But really, what makes it valuable is the unique serial number on it. So if you guys are sitting in a restaurant and two of it, everybody puts a dollar bill on the table, and you compare serial numbers, and you find $2 bills with the same serial number, what happens to the value of those dollar bills? Does it decrease by half? No. It destroys the value completely. So counterfeiting, those types of things. So cryptocurrency cases cannot have counterfeiting. In this case, everything has, to do that, you have a single ledger. So everything's recorded on one ledger. That includes the assets, like the Bitcoins or whatever you're creating. And then the accounts. You'll have a count as an individual that's registered on that network. And then that becomes very trivial once you and someone else is registered on that network. To transfer ownership of these assets becomes quite trivial using digital signatures. So we can create this transfer of ownership that's completely transparent and it's trustless. I don't need to know who you are, but I trust in the transaction. So when this model, that was the first thing that came out in 2009. Everybody jumped on it, started building these new platforms. And they started building them on top of Bitcoin. And one of the characteristics of Bitcoin is it has an underlying data structure called unspent transaction outputs. Now that's just early morning for that. Unspent transaction outputs is essentially making change. It makes change for you. When you make a transaction, you put a dollar down, and it's going to give you 65 cents back and 35 cents to the other person. It actually destroys the dollar bill. It tears it up and then creates two separate transactions that become unspent, and you get one of them. That's worth 65 cents. The other one gets 35 cents. Well, that model works really well for very short-lived transactions, exchanging currency. Then Ethereum came out and introduced smart contracts. So you think about economic development, currencies like cash, as we think about when we moved from the bartering economy, cash was very important. So we didn't have to worry about if I show up to the market with chickens and everybody else has chickens, we're not going to be able to trade. So if I show up with money, I know I can buy whatever I need. But that wasn't enough. We need futures. So futures contracts. So contracts, smart contracts provide this capability to create contractual agreements that are longer lived on a single ledger, transfer ownership, transparency, and trustless. A lot of the same things, but the major difference there was instead of destroying the dollar bill, and destroying that asset, it retains it. So when you deploy a smart contract, it gets a pinned address, which is very important. That means that you can have longer lived state for that transaction. I'll get back to that in a minute. But there's lots of problems here. Once you get out of, and you want to take this out of the public realm and you're trying to build consortium networks, you have these issues. First is scalability. This platform is very, very slow because of its trustless nature. Your smart contracts, the logic executes on every node on the network. So if you have 1,000 nodes on the network and you deploy a smart contract and you're not happy with its performance, and you say, well, let's scale it. What are you going to do? Well, I'm going to add 1,000 more nodes. Guess what? You just slowed it down because you added another 1,000 repetitions. So well, I'm going to beef up my server. Great. Well, it turns out when everyone is executing it, the slowest computer becomes that's your bar, the least common denominator of performance. So there's no scaling story there. So it becomes an issue. The second is external sources, because every node is executing the same contract. If your contract requires some sort of volatile data, maybe calculate something based on, say, an interest rate that might change, or a price, or some IoT device providing some information, well, that information, you can't have a smart contract. If it's executed on all 1,000 nodes, you can't have that smart contract go out and grab that data, because there's no guarantee that value of that volatile data is not going to change between the time span of all 1,000 nodes going to fetch it. And when that happens and that value changes, they'll never agree on the output. So they'll never come to consensus. That becomes a problem. Modularity becomes a significant issue. I'm going to spend a lot of time there. And then privacy is the other one. I don't want my transactions to be in the clear. I want to have some privacy. I don't want my, even if it's, my competitors are on the same network, they can see my behavior and make a market against me. I need to have privacy. So these problems that arose from these vendors, so you had lots of these vendors that went out and built UTXO-based systems off of Bitcoin. So Fabric, Chain, a whole bunch of other ones. Said, oh, these smart contracts are going to be pretty important. We need to figure out how we're going to support these. So they started coming out with these things called side chains. I'm sure some of you may have heard those. That's a scenario where you create a chain that's linked to another chain that does different things. You can have different sets of privacy. There's this new thing called state channels, which is the ability to have private transactions execute off-chain, but it's sort of still trustless. Partitioning the ledger, where you no longer have a single ledger, you have partitions of the ledger, which becomes sort of messy as well. And then blockchain oracles for injecting prices and volatile data into the blockchain. So all of these approaches become very confusing as you go in and you say, okay, I need to build a system, and I'm actually going to start writing. I have an existing application, I want to move to this. And you're trying to figure out, how in the heck do I get this to work? This system is crazy. It's like nothing else I've ever built before. You spend tons of time trying to understand mining and all the new programming languages and stuff like that, because it becomes a nightmare. So back in 2015, saw the interest in smart contracts and said, there's a fundamental flaw here. This thing is architected. If people want to do things on the public network, the architecture is fine. But if you're going to go into a consortium or a private network, this architecture is like tying both hands behind your backs and shoelaces together. It's really, really difficult to build solutions on top of. So what do? We paid attention to the gray hairs, well, particularly in my head, about all the painful lessons I learned when I went from client-server to 3-tiered architecture. How many of you did that transition? How many of you were Power Builder app developers? Anybody? Anybody remember Power Builder? Visual Basic? 2-tiered applications. You had a relational database in the back end. You had a smart client. Remember smart clients? We didn't call them smart clients. We called them, fat clients. Why were they fat? They had lots of logic and stuff in them. And we had a whole industry spun up just to deploy and maintain those fat clients in enterprises. It was just this massive thing. And that was our development platform. You had to figure out where I'm putting my business logic in the client, and I'm putting my data in the database. And don't put too much logic in the database, because man, Oracle's expensive, and if I do all my stuff in PL SQL and I need to move it over to some other database, I can't. If I have too much logic there, I need to make sure I can point to any database. So anyway, it became this sort of thing. So we said, okay, how do we address this? Let's talk about trust. What does blockchain provide us? At its fundamental level, it's a ledger. It's a database. It's a shared truth. So we call this the shared truth layer. This is our data tier, right? If we sort of abstract that away and think about a single logical shared truth between multiple parties, it's great to be able to say, counterparties to look at transactions on the ledger and say, yes, we trust that this value is the truth. But I don't necessarily trust the resolution of that truth. How do we then share the resolution of the truth in a scalable way, so that counterparties can not only trust in the value that's persisted on the ledger, but how it was derived? So this becomes the tiered approach. So we have a need to have a place where we can collaborate and share the resolution of the truth, and then we can persist that truth to a shared ledger. Two separate processes that need to be optimized. So let's talk about separation of concerns. One of the fundamental things that we learned when we went from client-server, well, actually from two-tiered, or single-tiered to two-tiered to now three-tiered. And three-tiered's been around for a while. You can argue about layers and things like that, but the fundamental premise of having a data tier, a middleware tier, a middle tier, a business logic tier, and then an application or a presentation tier. So the separation of concerns, when we follow this pattern, if we said, okay, let's not execute smart contract logic on the blockchain. Let's pull it off the blockchain. Let the blockchain do what it does in the database. Do store procedure stuff that's not proprietary that we can do, but use the power of that blockchain to do what it's good at. It's good at provenancing assets, transferring ownership of assets, and doing this transactions on that single ledger. Right? It's not good at doing things across another ledger. So if you're trying to move things to another ledger, that's a whole other ball of wax. So don't try to make that thing do that. Have it do what it's good at, and then pull that stuff up. What that allows us to do is allows us to scale and version independently. So we can version the middle tier differently with the data tier. It gives us flexibility in design. It also creates a new trust model. So down at the shared layer, we have sort of a shared trust model. But at the business logic execution layer, we have a discrete trust model just between the counterparties. Okay? So we don't have to trust everyone in the consortium. We can work with external systems. We can work with multiple blockchains at once. We can have portability. If I'm building a solution as an ISV, I want to write my application once, and if a customer is using Fabric, great, it'll work there. If they're using Ethereum, great, it'll work there. So this is what it looks like. Down at the bottom, we have the ledger, Enterprise Ethereum, Fabric, Chain, Corda. And then in the middle tier, we're calling it Enterprise Smart Contracts. You might have heard it called Criplets. That was what it was called before marketing got a hold of it. So Criplets is essentially the components that represent the business logic that's running in this tier. And then above that's essentially any other existing system. Existing technologies just plug right into that. So what are we doing at Microsoft? Well, several things. The first is we wanted to address the ledger layer. That's where we started. So we wanted to optimize that ledger. The first thing we had to do is, we have to make it easy for customers to roll out these blockchains. It's really difficult. It was when I started. So we wanted to do this in the cloud. So when you're building, you're testing, and you're doing POCs, you know you're going to fail the first couple of times. You want to do that in private. You don't want to go out on a public network and fall flat on your face. You want to be able to stand these things up. Do it cheaply. We call it the fail fast, fail cheap innovation platform. But essentially, it composes, it allows you to deploy private blockchain networks with these types of, this is essentially what we call a blockchain node. What it does, or what it's supposed to do. Some of the main things that we talk about it doing are things like transaction processing. It has this virtual machines, like Ethereum has the Ethereum virtual machine. Fabric has stuff like chain code. That actually has a VM behind it as well. We have consensus algorithms, which people spend an enormous amount of time on to figure out these things. But we take a look at these things and we said, we can make this thing better. I'll talk about how we're addressing that. The first thing we did was said, okay, let's make it easy for enterprises to deploy any type of blockchain. So we've done that. In the Azure Marketplace, you can deploy every major enterprise type of blockchain within minutes. Not just a single node network or a multi-node network with a single party, but you can deploy hundreds of nodes across multiple subscriptions and do it in minutes. Now this solves the deployment process. Rolling these things out is easy. Now maintaining them over time, that's something we're going to be addressing longer term because it becomes, you're rolling out these hundreds of network assets across multiple counterparties or multiple participants that are in different subscriptions. How do we have management tools that let you address that? So we're working on that with existing platforms. So you can go out and stand up these blockchain networks. Now, for all those companies and the business leaders are coming and saying, we got to do something with blockchain. We got to do something with blockchain. This was the answer to the technology folks desired. So I got to stand up a blockchain. So we made it ridiculously easy to stand these things up, which was a good thing. There's also a bad thing, because then they were like, okay, now what do I do with it? I need to build an app on this thing. How do I do that? It's really hard to do. This is all new stuff. It's bleeding edge, and I'm not staffed or skilled to do this. And it doesn't perform. You look at Bitcoin and Ethereum, the major knock on it, especially with the enterprise, they were saying, hey, it does like 7 transactions per second? That's ridiculous. We need to be in the thousands. How do we get there? So one of the things that we've done is, you may have seen this called the COCO framework. COCO framework is using TEEs, which is a abstraction for what we call enclaving. So Intel SGX is an implementation of this. It comes on Intel chips, and it creates an enclave where it essentially lets you run your code on an untrusted computer and know that it ran without being tampered with and confidentially, and it ran what it was supposed to run. So it provides some attestation to the code that's running within the enclave and its output, which is really, really powerful, particularly in cloud environments when you're deploying your logic, and you want to make sure that your logic isn't, if you're wanting to protect your intellectual property or you're having secrets like private keys to sign transactions, you don't want those things being out in the open. So enclave has become this really, really important technology that you're going to see over and over again. COCO is an implementation of using TEEs or enclaves that solves one of the fundamental performance problems, or several problems, at the data layer. So what it does is, when I have every node on that network, remember I have hundreds of these, or 10 or 20, when I use the COCO framework, I can run that node software in COCO and know that every other node on the network is running the exact same code, the bits completely, and its output can be completely trusted. So it creates a strong trust environment between the nodes, and it lets us get rid of these heavyweight consensus algorithms. In early tests, we went from 7 to 10 transactions per second into like close to 2,000 transactions per second, just by doing this. And that's not even optimized. So we can do things around governance and privacy at the data layer. Now this solves your data layer, well, it will potentially over time solve it. It's not ready yet. It will be open sourced and made available in 2018. But it will address that performance problem, to be able to show that performance jump that enterprises want to have, and it addresses a governance model for how you know who you're letting onto your network. So you don't want people just willy-nilly plopping a node on your network in a semi-trusted network. So COCO addresses that. Great. However, that's just addressing the shared truth. The place where we're building applications isn't necessarily down there. That's at the data tier. We're building things where we're resolving the truth. That's where our applications come into play. And this is what we call consortium compute, which requires a shift in thinking. So most of us, if you've been building applications for some time, even when you move to blockchain, your natural instinct is to build a siloed application on top of it for your company, which has almost no value in a blockchain and arguably shouldn't have been on a blockchain in the first place, because it's not built to be shared out of the gate. So you have to move from a mindset of single-party compute to multi-party compute. So it's this whole movement from I to we. And what does that mean? How do you do that? So let's talk about a layered approach. So if we separate our logic out from our data, and that means we can do things like, well, we can support all these different ledgers. We can abstract them away with an abstraction layer, sort of like ODBC, the printer abstraction layer, where we install printer drivers for the type of printer we're talking to. But your application above it doesn't need to know what printer it is, right? We can do the same thing here. We've been doing this for decades. So an abstraction layer where we plug in, we have this thing called a transaction router. We plug in these ledger connectors that know how to talk to those blockchain networks, and we abstract it. Now above this, then we have our shared execution environment. So the cloud just so happens to be a great place where counterparties can come together that no individual counterparty owns it, that's participating in this. They can show up in this market or this execution environment, come to some sort of contractual agreement and execute the logic for that agreement in the cloud and persist the truth along with its proofs down to the ledger, whatever one they're using, or two ledgers at the same time. You could persist a portion of the ledger to your private blockchain and then generate some sort of cryptographic proof and put it on the public blockchain. You can do all sorts of things when you start to separate these things out, things we're used to in the enterprise applications. So we have this shared execution environment where cryptlets that are built can run, and people can, and again, these are essentially templates. So these counterparties come together, and you'll see I talk about contract logic and external attested data logic in a minute. I'll get into that in a moment. But essentially, this is this shared execution environment in the cloud. And then on top of it, we just stand a standards interface on top of it. So open, we don't say it's an open API, but it is a standard messaging interface. I put RPC and REST in there. Lots of in the cryptocurrency place, they're all RPC based. Haven't really warmed up to enterprise service buses and things like that. But when you get to scale, you're going to go to a message bus system. We'll talk a bit about that later. And then some of the things you have to have in the middle tier, first is identity. We need to be able to authenticate users coming into our system. Once we've authenticated them, because we're using private keys for different networks, we then need to be able to get secrets, they're private keys. So we need to have key management that we map to identities. And then we need to be able to use those in the cryptlets inside our transactions. And then, oh, by the way, we want to have some data services on the side. Blockchains are notoriously bad to query against and do any sort of business intelligence against. So we want to be able to take those transactions and move them to like a data lake or a SQL server or something like that so we can reason over them. So this is the high level. What does it look like in reality? So this is enterprise smart contracts. Down at the bottom, we support all the various blockchains. Again, we plug in these connectors that have what we call contract proxies, and you have this transaction router. Above that, we have cryptlets. You have contract cryptlets and utility cryptlets, which I'll talk about the difference there. But these are cryptlets that come together. You write a enterprise smart contract, you post it, another counterparty comes in and joins, it binds, and then it executes. So the cryptlets begin to run your logic there. And then we have these attested external sources. So this is the main thing. How do I interoperate with and fetch data from volatile sources? I need to get data from my ERP system. I need to get market data from Reuters. I need to get IoT data from some sort of sensor. How do I get that stuff? We do that through utility cryptlets that allow you to retrieve that and then attest to the value and the source where that thing came from and feed it into our contracts. Above this, we're using AMQP. If you're not familiar with AMQP, it's a message standard from Oasis and ISO. And on top of that, you can put a REST interface on top of it if you want to. But essentially, you're working with messages. And you're working with strongly typed messages, which I'll go into in a bit. So we don't have like a wide open API. These things are running in enclaves. Enclaves have essentially a pinhole entrance as their API. So message in, message out. You can't have a broad API with a secure execution environment. So we use strongly typed messages. We're using Azure Active Directory for open federated identity. So most enterprises already use Active Directory. So that's sort of an easy in. Identity is one of those pervasive capabilities that we need in every enterprise blockchain. Azure Key Vault provides our bring your own key scenario where you have control over your secrets for your participants, and they're stored there. And then we have data lake and AI and ML and all that good stuff. And we plug that stuff in through a data aggregator that pushes it out to, say, Event Hub, which then you can then have different data sources pull or reason over that data. And also you can take events coming from Event Hub, from, say, IoT devices, and feed those into utility cryptlets. So lots of diagrams here. I'm going to quickly get into show some demos. as I set the stage. But let me describe the two types of cryptlets first, and the categories of them, what they do, and then we're going to go in and show you what this thing looks like, and get out of theory. So utility cryptlets, again, these are how do I work with external data. So the first thing we did was solve the how do I work with volatile data from external. If it's not recorded on the ledger, I can't go out and fetch it, because then I violate the deterministic nature of the code running at the blockchain layer. So I want to be able to go fetch data from a utility cryptlet or receive data, and then attest to that data's source and authenticity and provide it. So a utility cryptlet does basically anything you want it to do that's not contractual. So it's intended to be reused, multi-tenant, sort of horizontal, cross-cutting capabilities. Those are utility cryptlets. Blockchain oracles fall into this category. Contract cryptlets, this is where the real sort of rubber meets the road from a contractual standpoint. These essentially run within enclaves. These run in private. They are contract specific, although they're usually templates. When they're instanced, it's exactly the same code, just different counterparties with different variables. Just like any other contract, that paper contract you pull out of a desk and people fill it in on multi-part form, these are the same thing, templates. So contract cryptlets provide the cryptographic proofs of their authenticity and the output that they generate. Those proofs are then persisted to the ledger. So you can write these cryptlets in languages of your choice. Right now it's .NET based and JVM based. So that's majority of the enterprises want those types. So you're doing things in Java or C#, VB, F#, whatever. And then as customers demand other runtimes, we'll begin to move those in there. But we think we have the broadest coverage with those two. And we can do some pretty advanced things with cryptlets in those programming languages, as you know. So let's go into demo and show you what this looks like. Wake my system up. So I'm going to show you now. These are command line utilities. For any really good developer demo, it has to be a command line. It can't be some fancy user interface. So what I'm going to do is I'm going to boot up the Cryptlet framework. Get rid of some of these windows. Now, the problem with this is this thing is, again, modular, so it runs in different processes. We have things here. And I'm going to try to align these so you can actually see things that are going on. And one of the benefits of doing this is, let me describe what I've got running here, is I'm actually running the framework locally on this computer, but my blockchain nodes are in Azure. So I'm actually round tripping there. So it slows things down a bit, but it also allows us to see what's going on. If I let this thing run and it's local, it's scrolling so fast you can't tell what's happening in the background. So as I take a look at here, I've got I have this router, this Cryptlet framework router. I don't know if you can see that, but it's essentially that blockchain abstraction layer. And then I have this framework services. This is our sort of container runtime that manages those. And here we have an actual Cryptlet container that's running. And I'm going to begin interacting with it. And here is a node on a Ethereum network. You can see these. It's actually doing mining. And to interoperate with this, I'm going to use a command line interface to do a couple of things. Now, these messages, these strongly typed messages, actually serialize to JSON. And make this font a little larger for you. And I don't know about you, if you've ever tried to handwrite JSON, it's pretty brutal to do this. Fortunately, these types, when you see what I've done, how we've architected this, they're just classes, whether they're in Java or they're in .NET, and they serialize to JSON. So you don't actually have to work with the JSON, you just work with the objects, and then you send them, and they serialize for you automatically. The framework will serialize them in a common format. But for here, because we're using a command line and we want to be able to feed these things in, I want to be able to deploy a contract. So this is a command that is going to deploy this sample contract. And let me just change some of these fields right now. So this is a contract ID. So you'll know there's nothing up my sleeve. I've changed that. Night demo. Okay. So I've got those fields. I'm going to copy this, and I'm going to come over to my command prompt, and I'm going to paste it, and you'll see this thing work. So what's happening is you've seen it go out. This AMQP request and response has gone out. And let's see. It's not doing anything. It wouldn't be a demo if everything worked just right. Make sure this thing did not go to sleep, as I believe it did. There we go. So what's happened here is the transaction got picked up, got routed. You see this data up here. These are these cryptographic proofs that get generated. Essentially what I did is I called a constructor on this. And down here, if you can see this, it actually created a contract on the Ethereum network. And that Ethereum network then returns that, and it creates my enterprise smart contract binding. So this binding is represented by a unique identifier called a binding ID. Once I deploy my contract to whatever blockchain I want to, I say deploy it here, there, I don't need to know anything about that blockchain. All I need to know is the binding ID it returns back to me. And then I just use that binding ID to communicate with that contract to do whatever I want to. So in this case, you'll notice that I got back this binding ID. I don't know how well this shows up in the back, but it returned this GUID that I'm going to then copy. And I'm going to come into my command here, and I'm going to paste it here. And let's say I want to query that enterprise smart contract. I want to see what the values are. So I'm going to paste that command here, hit enter, and it's going to go out. It actually retrieves that from the blockchain the first time, and it sends that command, and it will eventually come back. Now, the first time, I don't know if you noticed, I put in there this little cache parameter. That's coming in. Make sure I didn't pause any of these guys. I did. There we go. And now I get back my result, Marley's demo, which I typed in before your eyes, and the Ignite demo. So I can see what the value is. So just querying the blockchain becomes that easy. If you ever try to do this, querying the blockchain with Web3 on Ethereum, it can be kind of messy. And it's very difficult to do. Here it's just formatting a JSON message. Now, let's say I want to buy that contract. So this guy has a buy contract because it is a contract I want to participate in. So I'm going to go buy this. And I'll just send in the buy contract message for that binding. And I'm going to paste that right here. Just paste it. It's going to go out, execute that command. It's going to go out and buy the contract and come back and give me a receipt. And it says that an object of the instance is not set to an object. That's great. Let's see what happened there. Probably usually a fat finger, some sort of. So the demo of this is capability. Oops. Let's query that guy again. I have a space at the end of the GUID. Yep. So let's try some other ones too while I'm at it. I'm going to deploy also a utility cryptlet. So this guy is going to deploy a utility cryptlet. This guy is actually going to be publishing. I better change this. Let's not do that. I don't want to do it every 15 seconds. Oh yeah, well, I'll do it every 15 seconds. So I'm going to publish the price of gold. I want the price of gold to be published on this blockchain every 15 seconds. So when I paste this command in here, you'll see it's going to, here's the price of gold. and I want it to be done every 15 seconds. I hit enter. It's going to go out and it's going to deploy. If I can hit enter here. All right, let me copy and paste again. I don't know what's happening in the system here. So I send this, it's going to go out and deploy that. You can see I have my contract has been deployed here. This is the contract address. And it's going to go create that enterprise binding. Now, on a mining network, you have to usually wait for just a little bit for the miners to all agree that that transaction is actually valid. It will return back this receipt. And once I get that receipt back, I'll be able to then turn this blockchain oracle on and actually use it. So you can see this mining delay right here, and now it's been committed, and I should get back my receipt with this new binding ID. Make sure I copy and paste it correctly. And then I can come in and I can query binding. So we have these types of commands. So I can go out and query a particular binding and find out data about it. And in this case, it's going to go out and give me the binding information. The one thing I need to pay attention to here is I'm targeting a specific cryptlet. So I get this cryptlet ID that has this unique identifier. I want to be able to then turn this binding on. Paste that. Oop, which wrong was it? Let me get this binding. 5A. This is why you don't want to do JSON hand coding. It's a lot easier to work with objects. So I'm going to come turn this guy on. I'll change 25 seconds is fine. So I go in, I'm going to turn this binding on, and you'll see this guy has come out and said, okay, he started this cryptlet instance. He's be updating the price of gold every 15 minutes. And we'll start to see that price get pumped in actually every 25 seconds. So we'll let this thing run for a bit, and then I'll come back and query that. So while that's running, let me show you what these things look like. So let's see how the font looks. Is that big enough? You guys in the back see? I need to increase that a little bit. So here's an example of this sample smart contract, and it's a standard Visual Studio project. We have our sample contract cryptlet, we have our proxy, which is our contract proxy, and then we have our types. These three projects allow us to then define how our enterprise smart contract will work. So the first thing we have, let's talk about the types. So if I start with, or let's start with a proxy. So a proxy is blockchain specific, and it's contract specific. So you use these connectors for various blockchains, and then you generate proxies for your contracts. So you essentially need to have schema. So in Ethereum's case, your schema is in a language called Solidity. So for those of you that are familiar with Solidity, this is what it looks like. But I'm using it just like a database. I'm defining schema using structs and little else. I do have some store procedure functionality in these things called functions. This is my constructor that does essentially nothing other than taking the values that's provided and create my contract details. And then I have a get contract details, just like a regular store procedure. And then I have a buy contract function as well. Visual Studio and Visual Studio Code automatically generate a proxy against this. So have any of you done Entity Framework before? You've done data first or data first implementations. This is that implementation. We're not doing code first yet, but we will get to code first. Code first is actually harder, but code first will be where you define your types and have it generate your blockchain specific schema. So we're taking this, we're automatically generating this proxy class. In this case, it generates a whole bunch of code for us that we don't want to have to write. So a whole region of generated code, and then we have a little bit of custom code that we write for that. The main thing that you do from this is you're working with types. And when you're talking about message interfaces, you're essentially defining your functions as messages. So here we have a constructor function. A constructor function is very simple. We do some basic things like deriving from base types, and we have the ability to, and these are just the properties. If you looked at the structs on the Solidity, we're just gathering the things that we need to pass to the constructor in this type. And we're using simple serialization attributes for these. Then we have get contract details, and you'll see this has a return type of sample contract details, which I can go to the definition of that. And these are my return types. So it derives from a base return message, which the framework uses those base classes to route things and format them and make sure those things are there. But we just define these APIs. It uses the command pattern, so you're submitting commands and retrieving a response, and just working with these objects. And then in your cryptlet, it's very simple. When I write my cryptlet itself, if I come up, a cryptlet defines this API in its constructor. So we have our sample contract cryptlet, which is deriving from cryptlet-based class, and it's implementing this, because it is a contract cryptlet, it implements this iContract cryptlet interface. And this is where we add our functions and our returns, just by adding these types. And what that does is it makes that externally queryable. So I can query the framework and say, hey, tell me what this cryptlet's API is, and it will return serialized JSON to me. Or you can just distribute the type library to people, and they can work with it that way as well. So we have some things that we're overriding, the activate binding. We don't have to actually override these if we don't want to, but you can in the samples that we provide you. Here we have our constructor, and then we're using attributes here to define the different message types. So when this cryptlet receives a message of this type, it's going to pass it into this function. So we're just attributing these functions or these methods with the types. Get state is not available publicly. Here we have get contract details. Again, we're just taking that type that we defined in our type library, and it gets routed here. We perform our logic. And that's essentially it. So what happens is the framework is listening to, in this case, service bus. Messages come in through service bus. They look at the type and the binding, and they get routed to the appropriate cryptlet. The cryptlet then does the behavior. Of course, authentication and all that stuff is done at the surface level and flows through, so OAuth tokens and things like that come through. And then it just executes your logic and then persists the logic down to whatever ledger. The cryptlet has no idea what blockchain it's talking to. It doesn't need to know. So it's pretty easy to approach, very enterprise developer friendly. These samples are a part of the step-by-step and hands-on that we provide. So for speed's sake, let's talk about surrounding capabilities. So once you deploy enterprise smart contracts and you get the ability to rapidly build these contractual-based systems that work across multiple blockchains at once and gives you that portability, then you want to light up all of the other capabilities that are available to you in Azure. And we're going to go into intricate detail on every one of these. I'm kidding. There's a ton of stuff. You guys have been here all week. So how do we then bring in all of these other types of capabilities into and to surround our enterprise smart contracts? And so yesterday we announced Blockchain Accelerator, or what's it called again, Mark? Application Builder. And what we're going to do is I'm going to bring Mercury up and Oscar from 3M to talk about their implementation.
Excellent. Thanks, Marley. So quick question. Who here has a mom? Oh, come on. Everybody has mom. So the reason I ask is I'm originally from Boston, and that's where my mom lives. And I saw something interesting in the news recently. There were a bunch of people that actually got sick from their medicine. And it wasn't they got sick from their medicine, it's that their medicine was counterfeit. And the result was they ended up getting something like sugar pills. And people ended up expecting to get better by their medicine, and they got sick. And so she's a grandmother to my kids, right? We want to make sure that mom stays safe and her medicine actually helps her as opposed to hurting her. So we looked at this with our good friends at 3M, and we realized just how big a problem this actually is. In terms of the amount of drugs in developing countries that are counterfeit, up to 30%. And of those, 30% just contain things that have no medicinal value whatsoever. So from a helping people perspective, it's really important to look at counterfeiting. And then from an enterprise bottom line perspective, it's a big financial problem. Just within pharmaceuticals, it's a $200 billion problem every year. And if you look beyond pharmaceuticals, it's a $900 billion problem. So one of the things, I happen to work in a part of Microsoft called Microsoft Digital, and we get to work with, it's a new part of Microsoft, and we get to work with a number of companies that are going through their digital transformations. One of those happens to be 3M. And I've talked to 120 customers, a lot of them in the supply chain space. And one of the companies that has probably one of the most innovative solutions, it's not just innovative, it's actually practical, is 3M. So I'm really proud to have Oscar here with me. And Oscar, could you talk a little bit more about what 3M is doing?
Yeah, absolutely. So I want to introduce you to Double Trust, which is the name of our solution. And this solution uniquely combines smart label technology with blockchain in order to provide label as a service. When you look at these smart labels, they are multi-layered, and each layer has a unique QR code. These QR codes are paired together, and the chemistry of the labels makes it really hard to tamper with, which it comes very handy, particularly when we have bad guys. These labels are also registered in a blockchain and validated, and they are assigned to a particular customer.
Great. So I know not everyone here is going to be familiar with supply chain. So let's talk a little bit about supply chain at a high level, and then I can ask Oscar how they're actually implementing the solution that's there. So if you think about you get medicine, maybe you go to a pharmacy down the street from you, but before you get that, it's going to go through a multitude of different parties to get there. So you can imagine there's raw ingredients. There's going to be someone who's going to manufacture that, so the pharmaceutical company in their factory. And then a mix of boats and planes and trains and automobiles and whatnot are going to get it to you. So what happens is there are a number of different parties, and what's going to happen is that as that box or that pill bottle is transferred from one party to another, they're going to ask to transfer responsibility, because what's going to happen is that as you move from one party to the next, they're now going to take responsibility and ownership for that. So if something happens while it's in their care, that's going to be a problem. So one of the things that we've done for App Builder is build that this is a fairly common scenario. We built a great smart contract that will help sort of navigate through this process. And that's going to help you look at things like provenance, so I can tell where it came from. And we've even layered on top IoT. So from an IoT perspective, we can track things like temperature and humidity. So we can identify, has this gone very, very hot or very, very cold? Now, if we look at medicine, that could actually alter the medicine that's inside the bottle and maybe make that ineffective. But one of the areas that we didn't have coverage for, and we didn't have smart contracts for, was how do we look at tampering, right? So we can detect the environment, we can detect where it came from, but how do we see if humans are actually going in and tampering with what's in there? And that's where I had a chance to talk to Oscar not that long ago. We just started talking about 6 weeks ago, and now we're on stage, so you can see how fast these things are going. Oscar and I sat down, and he had a great idea of what they're doing with 3M. So, Oscar, do you want to talk about that implementation?
Yeah, absolutely. So, if you look at the container that you want to protect, the idea is, so all you need for this solution is smart label and a phone. That's all you need. So you take the container, let's say this medicine bottle, you apply the smart label, and every time you transfer responsibility of this container from party to party, you scan the label. And all of those transactions, they go to the blockchain. So, so you go, and by the way, the application on the phone was actually implemented using Xamarin on top of App Builder. So it was very straightforward to implement, but it's also your entry point to all the services associated to the chain of custody.
Now, Oscar, now I think about 3M, I think about as a materials company. You guys created Post-its and other things like that. So are you guys going through some sort of transformation right now? This is a software blockchain solution.
It is, indeed. And in fact, it's kind of like freaking people out, because we are looking at this as label as a service, which is kind of weird, but interesting.
So I do have one question before we get to the demo. So it's going to go from party to party to party, and we're going to track that on the blockchain. And so from a digital perspective, we're going to be able to track where there are issues, and if it goes to a party and they see that it's tampered with, they can refuse to take it. But that's all on the digital side. We also make sure that there are visual cues that people can understand that things have been tampered with. So what has 3M done in that regard? How do I know if something's been tampered with based on the label?
Are you saying that there are bad guys?
There are bad guys out there.
So basically, what you can do is, I mean, the chemistry on these labels, it's again very unique. And if you try to tamper with them, like for example, if you peel the first label off, you're going to see the void signs that you have on the screen over there. And also, if you try to peel the whole label off, basically the whole package is going to come apart because the adhesive at the bottom is very strong. And we can customize these labels depending on the kind of container that you have. So it's very unique to that application for that particular customer. So, but you know, why don't we actually see a real demo?
Yeah, why don't we go ahead and do that, Oscar? We're going to do a switch over here to our Mac, which is on number 8. Do a little screen sharing. So as Oscar mentioned earlier, this is built on App Builder. So we're trying to figure out how to get started. We'll use App Builder, and our great folks at Xamarin helped out. Michael Watson and Madi from the Xamarin team put together this for us pretty quickly using the API that's available as part of App Builder. You can see here this is a mobile app. There we go. Hang on one second. And you can see here I can click on this. I can see which persona I am. So this is key when you're developing, because what's going to happen is that you can see that there may be 20 different parties that might be involved there. So who's the actual person here? So right now I'm representing Contoso Factory. I've initiated smart contracts. You can see that there's a notification that's there. And you can see some other contracts that we've done so far. And I can go ahead and click on these and get some additional detail. But what I want to do today, go back here. Oh, and we've just logged out. 1 second. So now you get to see the fact that we have authentication built into the app.
And I just want to reiterate that we started the project 6 weeks ago, indeed. And at that time we said, well, we're going to present it at Ignite. Here we are.
And I think most of that 6 weeks, Oscar, was actually time with lawyers, right? The development time was significantly less, just a couple of weeks, I think, all said and done. Okay. There we go, we're logging in. Okay, so these are different smart contracts that are available inside of the client, so we're using double trust. And I'm going to go ahead and create a new smart contract. Now, what was interesting is because we now have a mobile device, see, a lot of demos you see happen to use a web application. This is using a mobile device. So you now have access to all the sensors. You can store the sensor information on the blockchain. So this is going to use QR code scanning. But think about you've got a location with GPS and other things like that that can track where things are. So we've got the pill bottle here. I'm going to go ahead and scan this in this light. One second here. Use this one as a test. There we go. And you can see here that's going to ask me for the device. So this, remember I talked about that IoT scenario? Well, we've got this sort of merged in with that. So I'm just going to go ahead and pick Xamarin as our IoT device. Our supply chain owner is going to be, let's say, Contoso Factory. The observer, now the other thing is we talk about an observer, well, in many scenarios, the observer is going to be the government. There's public safety here. But say we'll just say it's Jim the inspector. And we'll track our humidity and our temperature. Say 22. I'm going to go ahead and click submit. And we're just 5 here on the surface. So, and then we're going to switch over to the surface. I'm going to sort of show you the end-to-end. So rather than doing a demonstration that shows 30 parties deep, we've got a little bit of a video that we're going to show you, and we'll sort of walk through that as we go.
Yeah.
So imagine you get your drug manufacturer. They're going to put these on the bottles. And then what's going to happen is we're going to have the first of our many parties come in. And they're going to go ahead and scan that label and take responsibility. So what's going to happen is that the drug manufacturer, Contoso, is going to say, hey, shipper, I want you to go ahead and take responsibility for this. They're going to check to make sure that the label is actually valid. So what's happening is it's going back to a registry. So they have their own supply chain for Contoso, but they're connecting back to 3M and their registry they have to validate that this is actually on the blockchain and is still valid. Because we also make sure that the label itself is not counterfeit, because that could be a secondary problem. Right? So we're verifying this. And we're also storing in the blockchain that it was shipped on this date. So we're tracking everything along the way, so we know who has ownership at any given time. In case there's a problem, we now have accountability in the blockchain. And what you're seeing is we're scanning it as we go through each step, and they're accepting transfer responsibility. Now, if we went out and we saw that this had been tampered with, then someone could say, I don't want to take responsibility, and there's sort of a dispute resolution smart contract, and go ahead and determine how would you handle that. Because you might want to go back and call the pharmacy and say, hey, should we actually move through with this or not? And depending on what you're shipping, they may or may not decide to do that. And ultimately, it shows up at your pharmacy. What's going to happen is the pharmacist is going to go ahead and scan it to make sure it's valid. Then they'll pull it back to get the underlying code, so they can say that not only is this valid, but we're now saying that it's reached its final destination. And so what happens then is on the blockchain, we're now saying that it's deactivated. So if anybody else tries to use this label, in the future, if someone tries to counterfeit it, it's not going to work. So you have this label which has two different QR codes. It's almost like a key pair. And then we're tracking both that it's valid and then it's where it's been. And then also, once it's been used, we can deactivate it. And that's going to make sure that my mom and your mom, when they get their medicine, that it's actually going to be the good stuff and hasn't been tampered with along the way. And see, if you look back, this is sort of the data you'll see on the blockchain. So you have all these different events that have been recorded and translated. You know, Oscar, you talked about this has been 6 weeks. So that's a proof of concept, but this isn't stopping at a proof of concept, is it?
No, in fact, this is not a demo. We have been working very hard on creating on a private preview, and we are basically at that phase right now.
And so the interesting thing is that when we put this together, we built this out with App Builder, but now we're ready to go. We know what the messages are. We know what the interactions are going to be. We're going to go start building this out next now using enterprise smart contracts and building that logic in for production, right?
Yes, yes. And in fact, we are looking for customers that would like to participate in our pilot program and that want to help protect grandma against bad medicine.
Excellent. Thanks, Oscar. And with that, we'll turn it back over to Marlon.
Thanks, guys. Okay, so that's always good to, let me see if I can get this thing off of here. Have a good, what's wrong with this thing? Yeah, it's not. Oh, there we go. So it's always good to have a use case for visualization to be able to show. But to sort of summarize and perhaps leave a little bit of time for questions. So at Microsoft, we're hard at work building a stack. And most people have been building with Microsoft some time. The stack is to make it easier for you to build applications. And the App Builder is a great tool for figuring out and getting your head around some of those. How do I move from I to we? How do I move from sort of a single-party system to this multi-party system? So we're focusing on all these layers, make it easy to deploy these things. We're innovating to make performance better at the data tier, providing you a common development platform and framework in the cloud that you can run both in Azure and Azure Stack, to be able to build applications and write them once and target any ledger, and in fact target essentially many ledgers at once if you want to do advanced type scenarios. And then of course this acceleration. So the App Builder itself is using that surrounding capability. It's bringing all of the capabilities, the IoT integration, the front ends, the mobile, the Xamarin stuff, and bring that stuff and take what you've built in your POC and your prototype and move it over. Again, once you've figured out your actual use case and how you're going to build these things. So we give you the tools and the steps to move from panicked, oh my gosh, we have to do something with blockchain, to 6 weeks later having something demonstrably viable with tremendous business value. I don't know about you guys, but this tampering thing, it seems complex at first until it gets stepped through and you understand how that thing is well thought out. Really, really impressive what 3M has done. And it's really, that type of innovation is what the businesses are super interested in, because this could be a game changer, right, for a whole series of transactions, and it occurs in every single industry. So our goal is, again, to let you do blockchain on your terms. We're not dictating. We're open platform, the open cloud. So use whatever blockchain you want to get the, use the public cloud, use the private cloud, use nodes in your own data center. But be able to integrate and use existing infrastructure, Azure Active Directory, Key Vault, bring your own keys, HSM's on-prem. We provide the middleware, the secure compute for shared resolution of the truth via cryptlets and enterprise smart contracts. And then having the enterprise assurance. So checking all the boxes with regulators, working with compliance certifications to make sure that if you build applications on Microsoft's blockchain platform, you're ready for prime time. So learning more, we have a booth down. Come visit our booth down in the show floor. It's over on the left-hand side when you come in pretty easily. We do have a solutions page up there. And then we do have communities on TechNet and MSDN that connect you to like Yammer groups and things like that. And we have lots of conversations going on, and some things that you can expect is enterprise smart contracts, the samples, the tools that I provided you will be made available this fall. So you'll be able to go out to Azure as a developer or an architect or just someone that wants to kick the tires and create an instance of this framework. Use Visual Studio either on that node or use your own on your local computer, and build and do the step-by-step to build enterprise smart contracts, to build blockchain applications, and do it within minutes and really get the speed very rapidly. So those will be available. The app builder we announced yesterday being available in a similar time frame. So we're ready for you to get started and giving us feedback. With that, I'll leave some time for, well, not too much time for some questions. But please fill out your evaluations. If anyone has a question, we have some mics around here, and we'll stay for a few minutes afterwards. But thank you.